Hello, thanks for listening. This podcast is on how to allocate and initialize an array in DLX. This podcast is presented by myself, Jeff, Mark, and Rhys. So firstly, by definition, an array is simply just a collection of items which are alike and of the same type. Later on in this podcast, we'll also explain pointers and how they're used and how they're relevant to arrays. We'll kick off with an example of initializing an integer array of size 100 in a high-level programming language such as C. Now we can see that each cell takes up 4 bytes of memory, being an integer, so the total memory required by the array is simply the number of cells times by the number of bytes taken up by each cell, in this case 100 by 4 being 400 bytes. Also, when we're given the memory location of the beginning of the array being cell 0, we can also work out the address of the ith cell by using cell 0 plus 4 times by I, as we can see in the slide. The same concept applies in DLX when we initialize an array. We initialize an array R of type word, which gives each cell 4 bytes of memory as required for holding integers. Now, the memory location of cell 0 is defined as R, so hence, to find the address of the ith cell, it's simply the address of cell 0 plus 4 times by I as we had previously, and in this case it's R plus 4I. The concepts discussed previously with integer arrays can now be extended to implement arrays of arbitrary types. So let's assume an array with n cells containing arbitrary items which each require storage space of m bytes. Hence, the total size of the array is again the number of cells times by the number of bytes taken up by each cell. So in this case, n times m. And assuming cell 0 has the address of R as we had previously, the address of the ith cell is simply just R plus I times by m. Okay, now having discussed this, I will now hand over to Rhys, who will explain pointers and how it's relevant in arrays.
Every memory location stores a number. These numbers can be integers, characters, or even addresses. A variable which holds an address is called a pointer. A pointer generally takes place of a register. Obtaining the value at a pointer is known as dereferencing the pointer. Here we have an example. The first load word instruction reads from memory location PTR or pointer, which is at memory address 100 in hex, and copies it into register 1. So register 1 contains the value 500. The second load word instruction reads from the memory location found in register 1 and copies the value found in this location into register 2. So register 1 we already know contains 500, and register 2 now contains the value 6, which was found in memory location 500. If you wish to get the value from variable or var, you require 2 reads. One first from PTR or pointer to get the address of the variable or var, and a second read from this location to get the value stored in var. So, if you want to get the value at the label var, you require 2 reads. One from the label PTR, which gets the address of the label var, and the second read from this location to get the value stored in var. A pointer refers directly to another value stored elsewhere in the computer's memory using its address. Pointers are used to hold addresses of entry points to subroutines. We have seen this already. Pointers can also be used to initialize arrays. Mark will go on to demonstrate how this can be done.
Thank you, Rhys. As we have just seen, a pointer is a memory location that contains the address of another memory location. A series of these pointers can be used in a consecutive manner to form an ordered data structure such as an array. This coupling of a data item with a pointer is known as a linked list. The first memory address contains the address of the data in the beginning of the list. A load instruction on this value will return the first data item. The next item in memory contains the address of data in position 1 of the list. And so the chain of loading a location and then loading a data point continues until the next pointer is null. An array behaves in accordance with a linked list structure. The concepts are related directly through each data point having an index or each data point being coupled to a pointer showing the location of the next data point. It was shown previously how an array is declared using DLX code with a label and a memory allocation directive, followed by the elements to be put in the array. Here the index is not explicitly stated as it would be in a high-level language. Rather, the index is found via addition of the size of elements between the initial pointer and desired pointer. This is the DLX representation of an array. In conclusion, we have seen how to initialize the array simply with allocating memory. And then it was shown what a pointer is and how it can be treated as data or an instruction in order to efficiently access memory. And finally, how a pointer and memory allocation can be used together to create an array in DLX. Thank you for listening.